Hello students, so it's long time to see you. So today I am going to start the first chapter of your 12th standard subject physics, rotational dynamics. Okay, so the name of first chapter is rotational dynamics. Chapter number 1, rotational dynamics. Okay, so this chapter is the combination of two chapters in previous syllabus. First is the circular motion and second is the rotational motion. Okay, so the first chapter half part, so we have already studied in the standard 11. So we will start directly here from the centripetal force and we will see the what are the applications of centripetal force. Okay, so now what is meant by centripetal force? So centripetal force is the force acting along the radius and directed toward the center. Okay, so let us start with the centripetal force because the basic we already studied in the standard 11. Okay, so let us start with the centripetal force. Okay, centripetal force. So what is meant by centripetal force? The force acting along the radius and directed towards the center. So if a particle is performing circular motion along the circumference of circle as studied in standard 11, and if the force is acting along this line and direct toward the center, then that force acting on this body, so body always lies along the circumference. Keep in mind. Okay, so this force is given by the formula F is equal to mv square divided by r, where m is the mass of the body, v is the velocity. So velocity means linear velocity and r is the radius of the circular path along which the particle is performing circular motion. Okay, so now see, so what happens? According to Newton's third law, so to every action there is equal and opposite reaction. Is that mean when there is a force directed along the radius towards the center, is that mean there must be a force directing away from the center also? So that force is called the centrifugal force. So let us start the definition of centrifugal force. Centrifugal force. Okay, so the definition is same. The force acting along the radius, and directed, just there is a little difference, directed away from the center. Okay, so as for every action there is equal and opposite reaction, so magnitude of both the forces is same. So this is also given by mv square by r. So this force can be written also like this, m omega square r, or also m into v into omega. So these are the different forms. We need just this one. Okay. So now we will see what are the applications of this centripetal force and how we use this centripetal force. Okay. So see, the next topic is application of the centripetal force on the horizontal curve rod. Okay. So very first we will study the horizontal curve rod. Which rod? Horizontal curve rod. Okay. Clear all. Okay. horizontal curve road. So curve means there is a turning. Okay, so if the road like this but horizontal means none edges of this road is made higher. Okay, if suppose we place the vehicle here like this is a vehicle. Okay, now see what are the forces acting on this vehicle. So force number one is the weight of the body directing always towards the center of earth, which is given by the mg. Okay, as the vehicle is on the surface of road, a normal reaction is given by the road on it. Okay, as the road is curve and vehicle is taking the turning, so there must be a centripetal force like this. mv square by r. Okay, so now let us draw the frictional force along this direction. Okay, so friction between the road and tire. Now consider a vehicle moving along a curve road of curvature of radius r. Let m be the mass of vehicle. Okay, let v be the velocity of vehicle. Now see, these are the forces balancing each other. So we can easily write the equations from this diagram. Okay, so let's try to write the equations. Okay, so now see, Fs is balanced by this centripetal force. So therefore you can write Fs is equal to mv square divided by r, equation number 1. Now n is balanced by the mg, so therefore you can write n is equal to mg. Now see what we are going to do. So equation 1 is divided by equation 2. So equation 1 is this mv square by r. So now let left hand side on the left hand side and right hand side on the right hand side. So let's divide it. Fs divided by n, and in on this side mv square divided by r, and here we are going to divide by this equation, so you can write directly mg in the denominator of this. So now see what mass it cancel. Okay, so I am writing here, so we will not need the next clip. So f by n is nothing but the mu. So we have already studied that in standard 11. Frictional force is directly proportional to normal reaction. So therefore F is equal to mu into n, where mu is the coefficient of friction, and hence we can write F by n is equal to mu. Okay, so this is the basic we need. So F by n is equal to mu. So therefore what happened? Mu is equal to what? V square divided by Rg. So transfer this to the numerator, we will get mu times Rg, and therefore V is equal to mu Rg under root. Okay, so now this is the maximum velocity with which vehicle can move along the curve road. Okay, so if we increase the speed greater than this, V is equal to mu r g. then the vehicle gets skids, means it's throw up the road. Okay, so and that is called the skidding. It is called the skidding. So what is mean by skidding? When a fast moving vehicle come on this road, okay, then what happened? It's thrown off the road. That process is called the skidding. Okay, so you have to keep in mind that you have to not exceed this speed limit. Okay, so the next topic is well up depth. So that is also depend on this much things, but the equation is different in that case. So let's see what is the well of depth. Okay, okay, so let's see next topic. The name of the topic is well of depth. So students, you might hear about this well update. This is in the ferry in which a bike rider, car rider moves their car along the vertical walls. Okay, and that is called the well update. So what we have to find? So we have to find maximum velocity or speed limit that should be maintained their vehicle along the that walls of the well of death. So let's start once again with the same diagram, but here a little bit difference like this. So this is say well of death. Okay, if a rider riding vehicle along this wall, suppose, so I am plotting or drawing here just a man, not the vehicle. If suppose he is riding his bike like this, then he must trace a curve path. Okay, so let's the R be the radius of this curve path. Okay, now vehicle or a bike rider is moving his bike along this wall. So this wall gives the normal reaction on this direction. So draw here the normal reaction. Let's change the color so you can understand better. Okay, so this is the normal reaction as usual. So vehicle is moving along the rider in the circular path, so therefore there must be a centripetal force which is given by the mv square by r. As usual, in the vertical downward direction his weight acting, and if suppose if this moving in the downward direction, then friction is along the vertical direction. Okay, so now what we have? We have four forces: normal reaction, centripetal force, frictional force, and weight of the vehicle along the rider. So you have to keep this in mind. Okay, so now let's start with the description. Once again, consider a vehicle. Consider a vehicle along rider has mass, say m. Let r be the radius of well. Okay, so now see, there are these forces. So you have to write which forces acting on the body in short. Okay, so now the forces acting on body. So before that we have to mention what is mean by V. Okay, so let V is velocity of vehicle. Okay, now forces acting on body. Forces acting on body. Body means vehicle with rider. Number one, weight. is equal to mg. So which is second? Second is the centripetal force. Centripetal force. Third is frictional force. And the last is what? Normal reaction. Okay, so centripetal force is given by this equation mv square by r. We started with this. Frictional force which is given by the fs, and normal noted by the n. So now from the diagram, at equilibrium condition, what we have seen, fs is equal to mg, so equation number 1, and n is equal to mv square divided by r. So once again we have to divide these equations. Okay, so I am writing here, please note it. Okay, so divide this equation. In the previous equation we get the fs divided by, and in this equation we get the reverse equation. Okay, so or you can write directly f by n is equal to mu. Okay, so now see, from this equation what we can write. Okay, so what is mean by fs? Fs is equal to mu into n, and what is the value of n? N is equal to what? Mv square divided by r. Okay, and what is mean by f? M into g. On both sides we can cancel the m here. Now transfer this rg to the numerator and mu to the denominator, where mu, once again, it is the coefficient of friction. Okay, so therefore what we can write, v square is equal to, now see, rg divided by mu. In previous equation this was in the numerator, in this equation this is in the denominator. So therefore what we will get, v is equal to under root what, rg divided by mu. Now what is this? This is the speed with which you have to ride your bike or vehicle in the well of death, else you will get sleep. Okay students, so here we complete our two topics. Okay, in the next clip we will see how the bike rider rides his bike without sleeping on the horizontal road, and why this sleeping or inlining along the road is not possible with the four-wheeler. Okay, so I am stopping here, and in next clip we will discuss that both topics. Okay, thank you.